Damn, feeling lucky. Out above most streets, us two in these streets, diamonds on my feet.
Hello, React Native developers. William here, presenting from beautiful Krakow. Software Mention, Expo, thank you so much for having me today. I'd like to show you two things this morning, and it's all about the GPU. It's about using platform-specific GPU APIs with a zero-cost abstraction, and it's about an industry-standard cross-platform GPU API. It's not exactly our DNA as React Native developers to use platform-specific APIs with a zero-cost abstractions, as well as leveraging robust cross-platform solutions to build incredible user experiences. So let's have a look. Last March, we released React Native Skia version 1.0. Part of the release was shipping the missing Skia drawing features, namely the Paragraph API and the Atlas API. After the release, we felt that it would be incredibly wasteful if Skia could only be used on the few selected data sources. With Skia, we have access to best-of-class drawing capabilities, but if we cannot use it on any kind of data sources, that would be a shame. Some data sources we are very familiar with. For instance, here we are using images, and we do an image projection using a shader. This is our bread and butter. A data source which I personally really like are vertices. So here we use it to map a texture onto a stripe of triangles, and we can create this beautiful organic effect. You can also use it to do 3D projections. So here our triangles are projected onto a 3D space, and you can also do some shading on the faces, and here it looks weird because there is no drawing order. But what we can do is do some depth sorting, and now the cubes render nicely. We call these examples 2.5D. So it's not 3D per se, because we do a lot of on-CPU operations, which would happen on GPU otherwise, namely the 3D transformation and the depth sorting. A data source that we introduced last year at App.js are native view snapshots. So here we access the bitmap of the native view to build effects with Skia. So for instance, here you see the Google map. It's not drawn with Skia. It's a native Google map view. We access the GPU, and we use it to build some sort of a transition. When we introduced it, it was very experimental last year, but we've received great community contribution that now makes the feature quite solid. 2 years ago at App.js, we had a workshop on Reanimated, and we had built this little sticker app. It was very clunky, but hopefully we had fun. And last year on stage, we showed the revamped version of the sticker app, and we wanted to show the deep integration between Reanimated and Skia. So what are we going to do this year? Let's have a look.
Hi, people. I'm Olivia, and I'm the organizer of this conference. I'm super happy to see you all here, and I hope you have fun.
Thank you, Paulina, and all the organizers for organizing such a great conference. This is a very special event. So, video support in Skia, how does it work? We get, you need to get a video file. We use Expo Asset for that, but you can use anything you'd like. You get a new hook called use video, and that returns a reanimated value that contains a Skia texture. And you can use it wherever a Skia texture is accepted. It can be an image, can be a shader, can be an Atlas component. And we also give you some access to playback options and some control options. For instance, here, we use playback options to build a boomerang effect. And we put the whole shebang together. So we have the vector graphics with the stickers, color filters. You see on the modal, the backdrop filters. It's all rendered with Skia. Sometimes the... no, sorry. So this is the same example than earlier. But here, of course, it's alive because we use a video instead of a static image. So wherever an image is accepted, you can use the same recipes, same shaders that you would use regularly with an image, with a video. Sometimes the most delightful effects are the ones you can feel but not see. So I'm going to play with you a short clip with React Native Skia. And I want you to pay attention and see if you can spot if there is something special about this video. It's going to be hard to catch, but let's see.
Welcome to another coding tutorial, and in today's video, I'm going to show you how you can make this cool, wavy, kinetic topography.
Did someone notice anything special? No? Okay. So let's have a look. Do you see a difference between, it's maybe very subtle between the left and the right? Some people are, yes. So that's called ambient effect, ambient mode. So what we're doing is that we're blurring the frame behind the frame that we're playing. And so if you're in dark mode, you get this delightful ambient mode effect. That's an effect that you would find on the YouTube app, for instance. So we think this is a very cool kind of examples. And as I mentioned before, you can use, with the React Native Skia, we have a library of shader effects you can use, and on images, and of course now you can use it on video, so I'd like to show you an example.
I hope you're having an amazing conference right now. I'm sending you some greetings from America to Krakow, and hope you will enjoy amazing talks, amazing food, amazing weather, amazing conversations. And I am pretty bummed that this year I'm not going to be there.
But we want to go beyond video. Again, if we can only use Skia with videos and only our own definition of what a video is, it would be quite wasteful. So to build this feature, we have built a new API. We call it native buffers. Like for React Native, the native part of the name stands for native. So it's a zero-cost abstraction to platform-specific GPU APIs, hardware buffer on Android, pixel buffer on iOS, and HTML image canvas source on web. With this API, we want third-party developers to be able to integrate with React Native Skia, stay on the GPU without needing to statically link against React Native Skia. And in fact, this feature was a collaboration with the creator of React Native Vision Camera and the founder of Margello, Marco Savi.
Hello App.js, Mark here, recording from beautiful Vienna, Austria. As we all know, Vision Camera allows you to run real-time processing on camera frames, and people from all around the world build amazing apps with Vision Camera. However, this was always a bit limiting because you could only analyze contents in the frame, but not draw back onto the camera. In the past months, William and I have been working on exactly this problem. We built a native buffer API for Skia, which allows you to convert GPU-based camera frames to Skia images, or GPU textures, in less than a millisecond. This allows you to draw shapes, points and lines, color filters, and shaders directly onto the camera. As a benchmark, we built this real-time face blurring app using the new Skia frame processors API from Vision Camera. This runs at 90 FPS. That's more than half a gigabyte of image data per second. My friends from Unbogify are already using this to analyze your golf swing so you can become the next Tiger Woods. Now back to you, William.
Thank you, Margello. Where is the team? I don't see Mark. I know Mark is here. Thank you, guys. What you guys are doing is very, very special. So congratulations to Mark and the whole team. What I really love about this feature is that in Vision Camera, React Native Skia is an optional dependency. Even though the two libraries deeply integrate with each other, you can still, we recommend you use Skia, but if you don't want to, it's still an optional dependency. And so we have reanimated, we have Skia, we have vision camera, and they're all optional dependencies with one another. And I think this is very cool. Another example that really caught our attention is Photo Booth AI. This is a French company, and here they use vision camera to do and Skia to draw the face and the eyes, and they generate an AI portrait. And this is a kind of high-grade user experiences people are building using vision camera and Skia. So we just released the features. Things are pretty early, but we want any third-party developer to integrate with this new API. And we are already aware of one open source effort in that direction, and that's ASAP. So they're building a consumer app, and part of this app, they want to provide a best-of-class video editor and encoder in React Native, and they're using React Native Skia to do it using the native buffer API. So this is not open source yet, but it will be later this year. And that's the first thing I wanted to show you this morning. Video support in React Native Skia, we have done it using native buffers, and we want third-party developers to use this API to integrate Skia onto any kind of data sources. And now, finally, I get to address the elephant in the room. And it's a big one. Earlier in the presentation, I showed you this example. And I mentioned that we call it 2.5D because we run on CPU a lot of operations that would happen on GPU otherwise, namely the 3D transformation and depth sorting. The elephant in the room is that, of course, Skia runs on top of fully fledged 3D APIs. So these 3D APIs are always available at the foundation level. And then we run Skia on top of it, and then on top of Skia, we're trying to build some features which were already existing. What are we doing? Qui peut le plus, peut le moins. What is going on? It turns out that this is somewhat of a fair situation. So this is the React Native Skia architecture. We run Metal on iOS, which is the iOS GPU API, and OpenGL on Android. So we could give you access through GSI to the Metal API, but then that would work only on iOS. And we could do the same with OpenGL, but again, it would work only on Android. So what are we going to do? We're going to apply a principle which is whatever the web does, we do. And what are people doing on the web? They use a unified 3D API, namely WebGL, and you can run apps. So you can run, for instance, 3GS to have like 3D models and applications. And for instance, if you use Skia compiled to WebAssembly, it uses the WebGL backend directly. So that's what people are doing on the web. So that's what we're going to do. We're going to use a unified 3D API across iOS and Android. We're going to run Skia on top of it. And this will enable people to run 3D libraries such as 3GS on top of React Native. So now we need a unified 3D API. What are we going to use? We're going to use OpenGL, right? No, we're not going to use OpenGL. OpenGL is deprecated on iOS. Skia has a new modern backend for modern GPU APIs named Graphite, and OpenGL is not supported because it's not considered a modern GPU API. And on a personal note, while working on React Native Skia and Canva.js, we had to write a lot of OpenGL code, and that was not really fun. We'd like to use something fun if possible. React Native developers, say hello to WebGPU. WebGPU is a fairly recent web standard. It's a GPU API. And in fact, the pixels you are seeing on screen right now are rendered using React Native. That's a new module we are working on. We call it React Native WebGPU, and you see here it works with gesture handler and reanimated. And we are building this new module around 3 use cases. The first use case is that we want to use WebGPU to modernize our Skia backend API. That's use case number 1. Once we use a unified 3D API across iOS and Android, we want to give you access to the API in JavaScript. So you can build applications such as this one or run libraries like Three.js. And finally, use case number 3, beyond graphics, we want you to use general compute capabilities of the GPU to do things like run AI models. So let's have a look at use case number 1. So this is the current backend that we use. It's called Skia Ganesh, and we use OpenGL on Android and Metal on iOS. And Metal is already a modern GPU API, so we can migrate it to Graphite. And OpenGL is not supported on the newest Skia backend. So we need to switch to Vulkan. And the only way we're going to migrate to Vulkan is that if we use WebGPU. And we use Dawn WebGPU, which is a C++ implementation of Google for WebGPU. So if we want to draw a single triangle with Vulkan, it's around 1,000 lines of code. To create an instance of one device object, it's around 20 lines of code. So we don't want to go there. The same way, when we write React Native code, we don't want to write 2 completely different apps. Here it's the same. We don't want to write too much Vulkan code, so we're going to use WebGPU. And that will enable us to migrate to Skia Graphite. Once we've done the migration, we can also use WebGPU on iOS. And as soon as we use the same 3D API across iOS and Android, we want to give you access to this API in React Native. When working on React Native Skia, we write a lot of backend-specific code, so OpenGL code, Metal code, and we plan to write even more. And here we would really like to use a single API and not have to do the work twice. So that's use case number 1, modernizing React Native Skia. Let's have a look at use case number 2. So this is the Canva you know and love, but now there is a twist. You get the reference of the Canva, and you can get a WebGPU context from it, the same way you would do on the web. And in fact, from there, you can just write WebGPU compliant code. Here, I have a bunch of geometry data. And the way you upload the data to the GPU is really fun. So here, I create a buffer. And it's funny because earlier, I was showing you these platform-specific buffers. But here, it's a cross-platform GPU buffer. And there is a mapped at creation property. It means that right now, the memory address between the CPU and the GPU is shared. So I can use it in JavaScript to write data to the GPU. Once I'm done, I can invoke unmap, and the data will be available only on the GPU. And I can execute a bunch of things. And if I want to read some data from the GPU, I can also create a new mapping again. And if we are compliant with the specification, we should be able to go on a website that runs WebGPU examples, copy-paste the code. Let's have a look. So I'm pasting the code, and here I do need to make one non-compliant invocation, which is context.present, which used to be part of the specification, but not anymore. And now the example runs out of the box. Here we took the default implementation. It's using time to rotate the cube, but of course we can use reanimated shared values and gesture handler to modify. So here I have the matrix transformation, and I'm adding rotate X, rotate Y, and it should nicely work as expected. Yes. This is the kinds of examples we are already able to run just by copy-pasting sample examples to React Native Web GPU. We generate the GSI binding from the specification. The way we do it today is very rough, but we're going to refine it. And we want to run this on the same test suite than any browser vendor would, to be fully compliant. Once we're fully compliant, we believe that we will be able to run experiences such as this one. So this is Free.js. While working on this project, we investigated how much momentum Free.js had with WebGPU. And we saw some very, very positive signals. And we think we are seeing some incredible opportunities. And so we hope that this is the kind of experiences we will be able to show on top of React Native Web GPU. But now, beyond graphics, you can also use this API to run general-purpose computations. So here in this example, I don't have a Canva. So this is a text. So this is a scroll view with a text components. And what I'm doing is a matrix multiplication. And the dimensions of the matrix is 512 by 512. So here we run the code through a shader in parallel, and we get the answer immediately. This would take a few seconds if you were to ask the CPU for the answer. And we think that people are going to use this to run machine learning models, such as this one, which run on top of a web GPU. So you can, you can upload an image, for instance, here, and the background is removed. And so we think that people are going to use also web GPU for building such experiences in React Native. And these were the two things I wanted to show you this morning. Video support in React Native Skia. We did it with native buffers, enabling third-party developers to integrate with React Native Skia and staying on the GPU. And React Native Web GPU, a new module we are working on, and we are building it with 3 use cases in mind. First, modernizing our Skia backend infrastructure, giving you access to this API to run incredible 3D experiences, as well as non-graphic APIs with machine learnings and AI. This is our vision for computer graphics in React Native. Thank you, Shopify, for supporting it. We are aligned, we are excited, and as we embark on this new journey with Web GPU, we will be keeping you posted every step of the way. And so indeed, I am looking forward to talk to you soon, and until next time, happy hacking.